Hello everyone, welcome to this tutorial. My name is Emerson Ahrari, I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to calculate heatwave index in Google Earth Engine platform using Python API programming and XEE library. In this tutorial, you will learn how to calculate the heatwave events for your own region of interest. This tutorial can be used for all around the world because all the satellite data and Python libraries and Google Earth Engine platform freely available, and you will have no challenge to deal with the satellite data in this platform. In this tutorial, I'm actually using Colab environment to write Earth Engine script and XEE functions. So now as you can see in this tutorial, you will learn how to make a heat wave event map that shows how many heat wave events occurred in your region of interest. My region of interest in this study is actually the Scandinavian country in the high latitude regions. And this is very simple and easy to use tutorial, and I will try to give you insight how to monitor heat wave events changes over the 20 years. And finally, I will show you how you can extract the heat wave events or number of the events experienced in one specific point for your region of interest. So if you want to learn these materials, follow this tutorial by the end. Okay, first make a new notebook environment in the Google Colab platform. In the first step, we need to call essential libraries. I'm starting with Google Earth Engine libraries. Import EE, Earth Engine library, and then import GEE map as GE. Or no, it doesn't matter if you actually use as something else or not. Just import GEE map is enough. Okay, in the next step, we want to call xArray function. The xArray library actually it's a library allowing us to deal with multidimensional data formats. So import xArray as xr. Let's run the code. As you can see, the Colab is connecting to the server, and after a few moments, the server connected and the code runs. So, once the essential libraries imported into the environment, then we can install the XEE. As the XEE is not available as a built-in library in the Python environment, so we need to install it first through this expression pip install XEE import XEE, just like this. After a few moments, automatically the XEE installed, and you can see successfully installed library. In the next step, we need to make a connection between Earth Engine and Colab environment. Essential libraries already called, and from now on, we need to make this connection because we want to use Earth Engine capabilities in the Python environment. So, from the Earth Engine library, first authenticate, there it is, and then initialize your account. The project name for your account. What is that mean? If you go to the code editor environment, in the upper right, you will see an option here that shows the account information through the project info. Here you can find the cloud project name. Every one of you has a specific cloud project name that you must copy and paste it, just like this. The another argument is OPT URL. If you search on the net about Google Earth Engine and XEE, there is a GitHub link that shows the complete, a detailed instruction about how to install XEE library and how to deal with the satellite data using this library. The OPT URL is also available here. Just copy and paste into your code. Now Colab asking permission for connecting to Google Earth Engine account. I'm granting the permission by clicking on my account and then continue and continue. Permission is granted. What does it mean? It means that from now on, we can use Earth Engine capabilities on their Python programming API. So, for example, now I need to make a user interface to select my region of interest. So let's make a new variable, for example, map from GEE map, one of the libraries already imported. Now I'm gonna call map function with a base map. For example, the base map will be the satellite. Let's print a map. Now we are actually calling a base map for selecting the region of interest. There is a global view with the satellite background, and now you can find your region of interest and draw and also identify it and identify the region of interest using drawing tools available here. For example, I'm gonna work on Scandinavian countries in this tutorial. So, through the draw a rectangle, I'm gonna make a rectangle for Finland, Sweden, Norway, and the other Scandinavian country that are detectable in the rectangle view. The rectangle is created, but we need it as a ROI, as a variable. So make a new code here and type a new variable as ROI. From the interface already called as map, now I'm gonna select the last draw feature. So that's draw last feature. I'm gonna have the last feature as a geometry, but sounds there is a problem here. Map object has not, yes, there is a typo. Draw last feature. Problem is solved, and let's print the ROI. As you can see, now we have a polygon with 5 vertices, including the coordinates of the selected area for the region of interest. In the next step, I need to call the daily maximum temperature data. If you go to the Earth engine, through the search places and dataset, you can call your target data. For example, I'm going to use daily ERA 5 data in this tutorial. Just type ERA 5 daily product. As you can see, ERA 5 daily aggregates product is available. Go to the description and click on this option to see the data product description here in a separate page. Through the Earth Engine snippet, we can call this product into Colab environment. Let's make a new variable as collection. Collection sets to Earth Engine image collection, daily ERA 5 data. Select the target bands. Actually, the select image collection, all of these functions are Earth Engine script. And thanks to EE and GEE map libraries, we can bring all Earth Engine functions into Colab environment easily and without any challenge. Okay, the target band is maximum air temperature because we want to calculate the heat wave index. So select the target band, it's the maximum daily temperature. Set a filter date that shows for how many years you need to call daily satellite data. For example, I'm gonna call the satellites from 2000 to 2020, for example. If you go to the data description, you will find the unit of measurement. In this tutorial, you can see the era 5 data, the unit is based on Kelvin, but we need to change it to the degree Celsius, meaning that we need to subtract the values from 273.15. It's actually constant value used for conversion between Kelvin and degree Celsius. Let's make a loop structure because we want to do this conversion for all data available for this period of time. Press on enter. In the next line, through the lambda, you can make a temporary function. For example, the input image considered as an IMG, and then each IMG or each maximum temperature is going to subtract from 273.15. This is a constant value always used for conversion between Kelvin and degree Celsius. Then copy the properties of input images to the output. That's copy properties img. I'm gonna copy properties from input with all information. img.property names. There it is. Let's run and collection is created. In the next step, we want to convert the collection to a data set. What does it mean, a data set? Here we want to convert the image collection to a X-array dataset, a multidimensional format. Once we convert the data format from a collection to the XEE or X-array structure, then we can apply all Python library of Python functions on the satellite data created or provided by the Google Earth Engine. This is a very, very interesting things because from now on you can have access to numerous functions that is not available in the Google Earth Engine platform. If you check on my YouTube channel, definitely you will find a lot of tutorials about XEE libraries. This is one of the newest libraries that allowing us to do a wide range of machine learning analysis on the satellite data. And this tutorial is one of the examples. Okay, now go to the next cell, a new variable as dataset creates from X-array library called open dataset. Okay, called the open dataset. The dataset input is the collection. Actually, I want to convert the collection to a multidimensional or X-array structure. Okay, and then sets engine to EE, CRS, the coordinate system EPSG 4326. The CRS here means the coordinate system, and EPSG is a unique code for WGS84 that is same for all around the world. The next is a scale. As we already have, as you can see, the coordinate system is EPSG WGS84, meaning that the scale should be based on the degree. What does it mean? Each 1 degree equals to 100 kilometer. So if you go to the data properties here, the spatial resolution is 27 kilometer. 27 kilometer means 0.27. There it is. And then the geometry, the region of interest is really important, equals to the ROI. Let's run the cell. And now we are waiting to convert a collection to a dataset. So here we have a dataset, a multidimensional array. As you can see, this is a multidimensional structure for the image collection. Now, actually, from now on, we are using Python capabilities on the satellite data offered by the Google Earth Engine. As you can see, we have a maximum temperature daily data for 20 years with more than 7,000 dates. It's very, very incredible because in the Earth engine we had limitation for 5,000 images, but from now on you can do analysis on more than 5,000 data. This is one of the big advantages. Why we say this is a multidimensional format? Because the time, longitude, latitude, and variable, each one of these actually showing a single dimension. Everything is separated in this structure. Time has own dimension, longitude, latitude, and also the variable. You can have a quick look on the data characteristic and longitudes, latitudes, and also the data variable. As we want to actually calculate the heat wave index, it is important to set the unit of the measurement in the data properties or the data attributes here. So for the data set or the target data set, select the target variable. The target variable is maximum 2-meter air temperature data. Select the target variable and then throw the attrs here. This is a function that's allowing us to add a new attribute to the existing one. The ID is attribute, data type is attribute here, and now we can add a new attribute to this list. So the new attribute will be or is units. The units will be like this, the degree Celsius. Just be careful because you must use the exact actually writing style. Unit is wrong. Unit is right because the index, the heat wave index needs some actually information before the processing, and also it's identified the unit of measurement through the unit description and also degree Celsius like this. Let's run and then print the data set again. After a few moments, here you can see a new attribute added as a degree Celsius. Now it is identified for the heat wave index what is the type of the data in the calculation. That is really matter. So in the next step, we need to call one of the most useful libraries available on Python for climate data analysis, and it is xclimb. Pip install xclimb and then import it. Import xclimb. Let's run. After a few moments, you will have this library installed successfully on your Colab environment. Okay, from now on, we can use xclimb functions on the Earth and on satellite data offered by the Earth engine, but you can't do this in the code editor environment. Okay. In the next step, let's identify the target function and get some information about it, about the arguments, how to use this, and also etc. Okay, from xclimb dot indices, I'm gonna actually find the heat wave index. As you can see, various heat wave indices available here. I'm gonna use the heat wave index. This is the target function in this tutorial. Through the help, you can find some description, a short description, a summary about the function characteristic and arguments and the output. The heat wave index returns the number of the dates, the number of the days that are part of the heat wave and defined as 5 or more consecutive days. Couple of arguments available here. One of them is maximum daily temperature, already offered by the Google Earth engine, And the next one is the threshold, the temperature threshold on which to for example, here, let's make it simplify like this. The threshold is 25 degrees Celsius and window is 5, meaning that if for 5 days in a row the temperature is 27 or greater than 27, meaning that we are experiencing a heat wave event. And remember that such values about the threshold values and consecutive number days actually it's not unique for all around the world. For some places, 25 degrees Celsius is okay, is a normal temperature, but for some regions, such as the Nordic countries, we can consider it for example, the heat wave or a very warm situation. But remember that for each place, you need to add the threshold that is consistent with the climate of that place. So, and also the number of the days and the threshold should be justified based on your region of interest. If you are working on the USA, if you are working on India, if you are working in Iran, for example, for all of these countries, you need to actually reconsider about the threshold value and the number of the days regarding to their climate condition. You can find appropriate data available on the net for these countries. For example, if you search on the net about the heat wave index in the USA, definitely there are some literatures that allows you to identify what's the best threshold for the USA, for example, western side or eastern side. And also you can find information about the window. But for a Scandinavian country, I prefer to use the normal and predefined values as they are, and just to show that how the heat wave index working. Okay, now make a new variable. For example, the index is a target variable, and from xclimb dot indices, I'm gonna call the heat wave index. The heat wave index, there it is, and make a parenthesis and enter the arguments. The first argument is the temperature data from DS maximum temperature selected. Okay, and the next argument is about the threshold. The threshold should be added like this. For example, the threshold equals or sets to, in a string format, 27 degrees Celsius to 27.0 degrees Celsius. Hopefully, the unit of measurement already defined in the data set. And the next one is the window. Window means the number of the days or number of consecutive days in which temperature is greater than or above this threshold value. So the next is the window. The default is 5, but you can update or justify it based on region of interest. And the frequency should be yearly. The output, I'm gonna actually see the number of the heat wave events for each year separately. Let's run the code. Typically, it takes 1 minute. If there is no problem on your code, if you don't have any syntax error, actually it takes around 1 minute more or less, depends on your kind of data, spatial resolution, the period of time, data volume, and etc. Then you can find the result without any challenge. If you have any problem regarding this code, first you can find the code example below this video on my YouTube channel in the description box. The first step, you can compare yours with mine. If a still problem exists, then you can reach me out. And when you asking questions, please refer to the main questions. For example, if you have a problem about the function, write the function and also add the kind of error you face in your code. That will help me to answer your question easily and without any challenge. Now, as you can see, after 1 minute, index calculated. Let's print the index to get some insight about the output. The output includes the integer values. This is a multidimensional array structure with the integer values. Each value shows the number of actually the number of the events or number of uh, heat wave events in which temperature increased beyond 25 degrees Celsius for 5 days in a row. Actually, you can adjust these values based on your region of interest. You're not forced, or actually you're not forced to actually predefined argument values. As I mentioned, depends on your region of interest. The arguments must be actually updated. So, and still we have longitude, latitude, and time, meaning that we can actually make a plot to show the variation of heat wave events from 1 year to another year. Let's make a new code, and the output name is the index, make a plot. So x dimension sets to longitude dimension, y-axis sets to latitude dimension, time axis sets to uh, sorry, the call axis sets to time dimension, and robust sets robust to true, because we want to avoid outlier impacts on quality of outputs. And there it is. And then call wrap, another argument. Call wrap means the number of image we want to have in each row. For example, let's consider 5 for this. We want to have 5 plots in each row. As you can see, now we have annual variation of the heat wave events, and as you can see, ranges from 0 to above 20 days per year. For example, sometimes you can see the number of the heat waves considerably increased in the Finland and Sweden, but for some of the years we cannot see any signs of the heat wave events. And also it's actually changing from 1 year to another year. If you want to actually have a simpler interpretation, because sometimes the number of the plots are too much and it's a little bit difficult to understand, or it's a little bit difficult to get insight about the variation. In these cases, we can resample the data to the 5 years, for example, maximum, or 5 years mean, average. Depends on your goal. For example, I'm gonna make a 5 years maximum image for this period of time. Then it is easier to understand the situation happening in this area. So index 5, for example, the index for 5 years equals to, get the index, then resample it to, for example, 5 years, the time dimension equals to 5 years, and then get a maximum value through the time every 5 years, just like this. Index 5, so this is index 5 dot plot, okay. X-axis sets to longitude dimension, y-axis sets to latitude dimension, call axis sets to time dimension, call wrap. So here we set a 5, and also maybe we have only 4 images maybe, or 5 images at the end. So the call wrap, I'm gonna see, for example, 3 images in each row, and robust sets to true, and let's run. Something is wrong. call wrap sets to equals. There it is. And now you can see the variations for each 5 years, 2000 to 2025, to 2005, 2005 to 10, 10 to 20, and also, sorry, 10 to 15, 15 to 20, and also you can see the 5-year variation actually highlighted here, and easily you can see in the first 5 years we couldn't see any heat waves in the Scandinavian countries, but it gradually increases, and also the number of the events increases. For example, sometimes we had 20 events per year in which the heat wave actually affected these areas, even with a very high latitude region. For example, in the last 5 years, you can see the very high latitude regions also experiencing the heat waves, and also meaning that it may have impact on the quality of life in this area and resilience of people against the temperature or something like that. So, and such kind of indices give us insight about how the temperature varies from 1 year to another year, and also we can get more information about the temperature changes and global warming. And also, if you want to change the name of the legend, you should rename this product. For example, here I'm gonna rename it to heat wave, just like that, and run, and let's run again. Now you can see the heat wave. Now it is updated, okay, with the unit of measurement. In the next step, actually, I'm going to show you how to select a point and plot the variations during the time. Maybe you want to see the history of a heat wave event for only 1 pixel. First, find your pixel in the Google Earth engine. For example, I'm working on Scandinavian countries, and I'm gonna select the Helsinki. 1 point in the Helsinki, I'm gonna see how many heat waves happened in this place over the 20 years. Here I have a longitude and latitude, and then I can make a subset from the image. So from the yearly subset, not 5 years subset, from the yearly subset, actually I'm gonna select the 1 pixel longitude, latitude. So the longitude is this for the selected point, just copy and paste. And the latitude is another one, just copy and paste it for the latitude. And the next parameter is the method of resampling. The method of resampling for the selected point should be nearest. The method equals to the nearest, meaning that find the nearest value to this coordinate. Let's run, and now you will see we have 1 pixel values through the time. This is 1 pixel, and also this is the time information, and you can see the range of heatwave events through the time. In the next step, I'm gonna convert this to a data frame for the actually extra analysis. It's very easy to do. So a new data frame created equals to get the subset and convert it to a data frame, just like this. The data frame is created. Now the same multidimensional structure converted to a data frame. As we don't need the longitude and latitude for anymore, so let's only select the target variable. So the target variable is selected like this. Let's run, and let's run again. If you want to have this data frame, just call the pandas first as PD, and then save the data frame to CSV format. So to CSV, this is heat wave events. .csv format. Let's run. In the left panel here, you can find the heatwave CSV, and you can download it like this easily without any challenge. Okay, let's go to the next step. Now I'm gonna make a plot from this data frame. It is also very easy. Just type the data frame and then dot plot. Here you can see the number of heatwave events for the selected pixel, and now you can see the history of the heat waves for the selected points. And as you can see, as after 2005 and 2008 or 9, the number of heat wave events actually increasing, and also there is a considerable increasing trend in the heat wave events in this area, as we already saw on the maps, and also it was clear there is an increasing trend. I hope you liked this tutorial as much as I did. I tried to give you some insight about how to deal with climate data in the Google Earth Engine platform and XEE libraries. There are various indices on the Python API, on the Python programming that you can apply on Earth Engine satellite, the Earth Engine, the data available on the Google Earth Engine. Please share this tutorial with other people who are interested to remote sensing studies. Thank you for your attention.